to 225 gram of water. So apa yang saya ada first and foremost, I have a metal. Okay. And this metal right now weighs 0.55 gram. The initial temperature of this metal, T initial of this metal is 99 degrees Celsius. And what do I do is I'm going to put this metal into a beaker of water, where in this water, the mass is 225 grams. The initial of the water, the T initial of the water is 22 degrees Celsius. And then soalan sambung, the temperature of the water. If the temperature of water rises by 1.7. So in the other words, the delta T of the water right now is 1.7. Agree? So this is what given. If the delta T given of the water is 1.7, can I say that the T final of the water is 23.7? Do you agree with that? So far? Setuju? Okay, ya? Alright, kalau setuju, sayang, fikir logik je. I want you to think logically. Alright, kalau kamu ada satu besi yang panas, kamu letak besi panas tu dalam air sejuk. Sejuklah 22 darjah Celsius. Satu yang panas, letak dalam yang sejuk. Siapa yang akan membebaskan haba?
Panas.
Panas.
Yang
Obviously,
panas.
panas akan membebaskan haba. So the Q release, like I said, the main thing about calorimeter is someone is going to release the heat. So find who is releasing the heat and someone is going to absorb. So the heat is released by the metal and obviously dalam ni siapa akan absorb? The one that will absorb the heat is definitely your water. Agree so far? Setuju? Make sense? Okay. Kalau make sense, soalan saya next adalah yang penting. Kalau kamu kata metal will be releasing the heat to the water, can I ask the T final of the metal rasa-rasa lebih tinggi daripada 99 degrees Celsius atau lebih rendah? The T final of the metal.
Rendah.
Teka? Dia dah bebaskan haba. So rasa-rasa dia akan jadi sejuk ke dia akan lagi panas?
Sejuk.
Sejuk. Anis kata sejuk, dia akan jadi sejuk. Okay. And the main key things about this question, satu je. This one. What do you think the T final of the metal will be? Rasa-rasa T final untuk logam tu berapa? Anyone?
23.7.
Yes, the T final akan jadi 23.7 degrees Celsius. Very good, Anis. Kenapa 23.7? Sayang, fikir logik balik. I have a metal that is super hot. I have a beaker of water. Saya letak logam tu dalam air. Dan kita kata logam tu akan membebaskan haba. Betul? So, bila logam tu akan berhenti membebaskan haba? When will the conversion of heat will stop? The conversion of heat will stop when the metal and the water is the same temperature. Betul? Haba yang diorang ada sama. So, the conversion of the heat will stop when the T final is the same. This is the key thing. Alright? This is the key thing. Beza soalan ni adalah biasa kita akan ada delta T yang sama. Kalau kita guna MC delta T atau C delta T, normally the delta T is the same, right? But right now the delta T is different. Okay? So we already have the mass, we already have the delta T, and the question is asking for the C kecil of the metal. We are looking for the C specific heat capacity of the metal. So obviously, quite obvious, the formula that we will use is MC delta T, M for metal, C kecil untuk metal, and then delta T untuk metal equals to M for water, C for water, and delta T for water. Everything adalah sendiri punya. So mass of metal 0.55, I think that is quite obvious. C metal is the one that we are looking for. Delta T metal, you can work it out, 99 minus 23.7. All right, equals to the mass of water 225 C kecil water berapa? Soalan tak bagi. So kita guna. Soalan tak bagi. So kita guna.
$4.18.
4.18. Thank you, Anis. So boleh dapat C kecil. Soalan senang kan?
4.18.
Thank you. Can I have the final answer, Amira? Can I have the final answer, Amira? Hani?
1710 joule per gram per darjah Celsius.
Sekali lagi, Hani, baca.
1710 joule per gram per darjah Celsius.
Saya dapat lain. Saya tak dapat 1000. Yang lain? Anybody? Nabila?
38.
38 saya dengar. Tak dengar suara siapa. 38.
38.61.
38.61. Agree with that? Ke saya salah kira? Setuju ke?
1710.
Okay. Setuju ke? Line kamu tu.
38.61.
Yup. Alright. Setuju? Your line is really bad. Everything is so drag. Ada yang dengar on the spot, ada yang dengar lambat. Oh my god. Anyway, yes, I think the main thing about this question, the main concept about this question adalah T final. Kamu kena realize the T final adalah sama. Okay, when kamu ada benda panas dalam benda sejuk, the T final must be the same. Okay, so that is the one. And I remember Ani say 3, 4, 7. So question number 4. Okay. So let's try question number 4 over here. Apa benda soalan ni? In an experiment, 0.1 gram of hydrogen and 0.8 gram of oxygen were compressed in a 1 liter bomb, which was then placed in a calorimeter that has a heat capacity of this. Lukis sikit lah weh. I have a bomb calorimeter. Okay, I have a bomb calorimeter. Inside the bomb calorimeter right now, I place in 0.1 gram of hydrogen gas. I place in the same thing, which is 0.8 gram of oxygen gas. This calorimeter is volume of calorimeter is 1 liter. Okay. The calorimeter having a heat capacity. So heat capacity C besar, C kecil sayang?
Besar.
C besar. C besar calorimeter equals to 9.08 times 10 to the power of 4 joule degrees Celsius negative 1. The initial temperature of the calorimeter measure was 25 degrees Celsius. So the T initial was 25 degrees Celsius. The T final given 25.155 degrees Celsius. Straightforward, delta T 0.155 degrees Celsius. Betul? Okay. So the question is asking for calculate the amount of heat given off in a reaction between hydrogen and water, oxygen to form water expressed in kilojoule per mole. So what's the question having the reaction over here is you have your hydrogen gas react with oxygen gas forming your water. First question, okay? What is this enthalpies? What enthalpies is involved over here?
Formation.
Alif, formation correct? Formation of apa Alif? Formation of siapa?
Formation of water.
Formation of water. Okay. Saya nak tanya satu lagi. Selain daripada formation of water, ada orang perasan tak dia enthalpy ada? Dia selain daripada formation of water, dia juga adalah enthalpy satu lagi. Anyone? Tak perasan? Tak ada? Yes or no? Kalau formation of water, 1 mole jatuh pada air. 1 mole kan? Kalau combustion of hydrogen gas, 1 mole jatuh pada hydrogen gas. 1 mole kan? Sama tak? Okay, but most of you doing this. Okay, I'm happy. Either one will do. Alright, either one will do. Because what most important right now is you need to know what are you calculating for. Alright, so kalau kamu jumpa formation as your answer, I'm happy with formation. Keep the formation, it's fine. Okay, so right now you already know what you're looking for. We are looking for the enthalpy of formation of water over here, like Alif and most of you guys saying. So right now we need to calculate the value. So first and foremost, before we calculate the value, we go for your calorimeter concept first. So the heat released over here, the heat released by the reaction. My question, absorbed by siapa? Ada air? Do we have water? No. Do we have solution? No. Do we have calorimeter? So we only absorb by calorimeter. Dah selesai yang ni, only 2 formula. MC delta T, C delta T. Yang mana? MC delta T or C delta T?
C delta T.
Betul. So C delta T, C delta T. So C besar kita 9.08 times 10 to the power of 4. Delta T kita adalah 0.155 degrees Celsius. So kamu akan dapat jawapan ni dalam joule, and like I said last Monday, it's better to change it to kilojoule because your value will be smaller. Okay? Tapi dengan syarat siapa yang tukar kepada joule dan kilojoule, satu je Miss Wong minta letak unit yang hang tukar tu. Okay, letak unit yang kamu tukar tu. So if I'm not mistaken, you got, correct me if I'm wrong, saya pun kira tadi je. No, not this. You got over here, yeah, correct. 14074 tukar kepada kilojoule 14.074. Am I right? Sebelum saya move on, ada masalah setakat ni? This one ada masalah? Boleh Senang Yang ni je calorimeter. Yang lain semua tu adalah mole ratio. So, the question right now are giving you 2 reactant. The reactant that I have is 0.1 hydrogen gas and 0.8 gram of oxygen gas. Tapi kalau kamu nak guna untuk combustion, seperti yang semua setuju, semua orang nak tengok pada formation. So, saya nak yang ni. Saya nak kira formation, saya hanya boleh compare dengan berapa banyak water is produced. Water is a product, ladies and gentlemen. Water is a product. I have reactant over here. We learned it last semester, topic 1. 2 perkataan. Limiting reactant. Remember that thing? Okay. Dan nak kira limiting reactant, boleh guna mass tak kawan-kawan? No, Lau say no. So Lau, what do we do to the mass?
We need to calculate the mole for the H2 and O2.
Yes, we change it to number of mole. So number of mole of hydrogen gas over here using the mass 0.1 gram divided by the hydrogen 2 gram per mole, you got 0.05. 0.1 bagi 2, 0.05, betul kan? Kalau salah bagi tahu saya pun congak je. Oxygen gas 0.8 divided by 16, 16, 32. 1/4. 0.025 mole. Correct? Okay. So far so good? Boleh? Alright. And next thing adalah limiting reactant. You need to determine who is the limiting reactant. Kenapa nak cari limiting reactant? Sebab yang saya nak adalah produk. So siapa yang menentukan produk? Limiting reactant. So kind reminder about limiting reactant, both of these adalah given. Alright, both of these adalah given. So from equation, 1 mole of hydrogen gas will react with 0.5 mole of oxygen gas. Okay, so given 0.05 mole of hydrogen gas, how many mole of oxygen gas do I need? Same thing, 0.5, kamu akan perlukan 0.025 mole of oxygen gas, and that is what you need. I really hope that you remember your limiting reactant because I really don't have time for that. If you remember, when the given over here is the same as the needed. When the given is the same as the needed. Apa maksud dia? Maksudnya both your hydrogen gas and your oxygen gas are limiting reactant. Oh my God, Mr. Lim. Mr. Lim macam chip semua hari ni. Kejap ada, kejap tak ada. Dia masuk tak sampai satu saat, dia keluar. Oh God. Your internet is horrible. Not you, not your fault. Definitely, it's just I'm saying that the internet is horrible. Nothing to do with you. Definitely not your fault. What can I do to make you have a better internet? Where we are? Agree both adalah limiting reactant? Okay, so kalau both adalah limiting reactant, siapa yang kita nak pilih untuk compare dengan produk? Kalau kamu pilih hydrogen gas atau oxygen gas? Mana yang senang? Laila? Mana yang senang, Laila? Your internet is just horrible. I hope it's because your internet is horrible, that's why you are not answering. Apa jangan buat internet slow, lepas tu tak nak jawab lah soalan Miss Wong. Don't do that. Alright, saya kutuk kamu betul-betul yang tu. We are using, I will choose hydrogen. If you choose oxygen pun betul, tak salah. I will choose hydrogen sebab dia 1-to-1 mode, nampak senang. Okay, so bila kamu nampak from equation sekali lagi, 1 mole of your hydrogen gas will produce 1 mole of your water. So hydrogen gas ada 0.05 mole. Automatically you will form 0.05 mole of your water. Okay? And the most important part dah sampai. 0.05 mole of water only release negative 14.074 kilojoule. Kita nak delta H. Kita nak enthalpy of formation of water. Alright, kita nak yang ni. Kita nak yang ni tadi kita cakap dah. So, untuk dapat yang ni, how much is that? 1 mole of water will be equals to how much? Setuju? Are we still together? Irfan, are we together? Jawapan akhir berapa, Irfan? Tak nak bagi jawapan akhir. Sebab line kamu tak okey kan, kamu kira sendirilah. Cuma saya nak ingatkan jawapan akhir tu make sure ada negatif, make sure ada kilojoule per mole. Tu je saya nak tekankan. Tekan kalkulator sendiri. Okay, tekan kalkulator sendiri. Ada soalan setakat ni? Anis okey? Betul ke Anis?
Okay.
Betul so far? Okay. Yang lain? Okay ke? Alright, awak semua sedih je hari ni. Kelas saya tadi ada budak lelaki seorang sedih gila. Dia macam murung gila dan sebab orang yang positif tu datang lepak kat bilik dia selalu. So, dia pun murung lah gila, lepas tu sedih gila. Aku macam, dah berlalu pakcik dah berlalu. Move on. Just, take good care of yourself. Alright. 7. Betul Anis? Okay. Soalan 789 ni adalah soalan yang sama bentuk. Saya memang nak bincang. Alright, saya memang nak bincang salah satu. Anis pilih soalan 7. So let's see soalan 7. Okay. Soalan senang je. Slightly different. As I promised, your calorimeter ada dua. Combustion dengan neutralization. So combustion yang kita dah bincang kat atas tadi. Alright, banyak yang kita dah bincang adalah combustion. Sekarang kita nak bincang neutralization. So what is happening in the neutralization? Fahamkan soalan dulu. 200 cm³ of 1 molar NaOH was added. So saya ada simple calorimeter. Okay, saya ada simple calorimeter. Dalam ni, kita masukkan yang pertama, 200 cm³. Mr. Lim, you're like chips more, Mr. Lim. You're here once and then you're missing the other second. Okay, you have 200 cm³ of 1 molar NaOH, and then another one is you have 300 cm³, 1 molar HCl. Okay, the temperature of the solution increased by 5.4 degrees Celsius. Delta T is 5.4 degrees Celsius. Okay. Calculate the delta H of neutralization. We are looking for this. Alright. Dan apa yang soalan bagi along the way? Specific heat capacity of solution. So yang dia bagi kat sini adalah C kecil solution. C kecil solution 4.2. Assume the density of that solution is density of water. Density of solution equals to density of water 1 gram per milliliter. Okay. Setakat ni, ada yang tak faham? Tak ada. Saya nak tanya lebih lagi. That is the delta T. I have 200 of base. I have 300 of acid. Can I ask, what would be my volume of solution? Can I ask about solution? What would be my volume of solution? Anybody?
500.
500 cm³. And next, how can I change the volume of solution to mass of solution? Mass of solution berapa?
500.
Thank you Hani, thank you Anis. 500 gram. Sebab apa? Saya nak ulang density yang kita buat semalam. Density of solution will equals to the mass of solution in gram over volume of solution in milliliter. Density adalah 1 gram per milliliter. Mass adalah yang kita nak cari. In gram, volume 500 milliliter. Masukkan, kamu akan dapat mass solution 500 gram. Setuju? Okay, am I moving too fast? Okay ya? Alright. Kalau okay, saya nak padam dah dan segi ni tak guna dah. Kamu dah tahu dah nak dapat macam mana. Okay, selesai kat situ. Next thing. If we are talking about neutralization, ladies and gentlemen, we are talking about neutralization. Quick question. 1 mole jatuh pada siapa? Yang ni semua boleh jawab weh. Buka mic jawab.
Water.
Thank you. Kelas ni nasib baik ada Anis, nasib baik ada Alif. Alright. Kalau thank you Natasha, thank you. Kalau tak kelas ni macam saya cakap dengan dinding. Tahu, dengan line teruknya. And everybody knows that water is a product. So, kalau 1 mole, soalan budak suka tanya benda ni. Bila masa nak buat limiting reactant? Budak suka tanya benda ni. Bila masa saya nak buat limiting reactant Miss Wong? Bila 1 mole tu jatuh pada produk? Kalau 1 mole tu jatuh pada produk dan kamu ada information pasal reactant, that is your reactant actually. That is your reactant. Kamu ada info pasal 2 reactant and you're looking for the product. That is the time your limiting reactant come in. Okay? So kamu kena buat limiting reactant. Dan sebelum kita buat limiting reactant, I think whenever you have neutralization, it's very important to get the balance equation. So balance equation yang ni tutup mata boleh buat NaOH aqueous tambah HCl aqueous. Yang ni tak boleh buat. Aku tarik balik result SPM apa, aku suruh ambil balik SPM tu sekali lagi. Walaupun you don't know what you have done last year to get the SPM result. Right? What have you done in the past 2 years? Have you done anything? Have you get better? You'll be like, I don't know what have happened, but I passed my SPM and then I got into matrix. Right? Okay, so that is your equation, first thing. Dan yang kita nak pacik ni. Okay, yang kita nak pacik ni. So, before anything, to get this, kita kena tukar semua benda kepada number of mole. How do I change this to number of mole? Can anybody tell me how can I change this to number of mole? What formula can we use? Sekali lagi, Anis?
MV/1000.
We can use MV/1000. So, number of mole untuk NaOH will be equals to the MV/1000. Taking the molarity of the NaOH adalah 1, volume adalah 200, divide by 1000. So over here, I'm getting 0.2 mole. Betul kah? Lau, thank you. Okay, next number of mole adalah number of mole of hydrochloric acid. Sama, kita masih akan guna MV/1000. The molarity that I have over here is still 1. Volume adalah 300 divided by 1000. So you're getting 0.3 mole. You got the number of mole already. So what is the next thing that you will do is you want V1. Sayang, kita tak nak number of mole 2 orang ni. Saya bukan nak diorang. Saya tak nak diorang. Number of mole yang saya nak, water. Kenapa number of mole yang saya nak adalah water? Because I'm looking for neutralization. In neutralization, we can only look at water. Okay, so I'm looking for the water. Before I move on, just a kind reminder again about your limiting reactant. That is the one given. So I want to find my limiting reactant. I want to find my water is how much. So from equation, okay, 1 mole of NaOH will then react with 1 mole of my HCl. Saya ambil given 0.2 mole of NaOH. So it's a 1-to-1 ratio. Therefore, 0.2 mole of HCl is needed. Okay, are we still on the same page? Okay, yes, ngangguk Hani, all right. Okay, so if we are still on the same page, then we go for the limiting reactant. We compare the number of mole HCl needed. Yang diperlukan adalah 0.2. Alright. Lebih kecil daripada number of mole HCl yang given. Yang diberi lebih banyak. Kalau yang diberi adalah lebih banyak sayang, HCl, excess atau limiting?
Excess.
HCl is excess reactant. Dan kita hanya ada 2. Bila HCl adalah excess, automatically our NaOH is limiting reactant. Kita tak masuk apa-apa pasal calorimeter sayang. This is all your semester 1. Alah, semester 1 yang hampa tak kisah hari tu. Alah, kan objektif yang hampa tak kisah tu ha. Welcome back to second semester. Alright, that is your limiting reactant. And from this limiting reactant, ladies and gentlemen, from this limiting reactant, we can find the number of mole of your water. Tak ada tempat, saya contoh sikit lah. From equation, 1 mole of NaOH, kena compare dengan NaOH, produce 1 mole of water because that is the limiting reactant. So NaOH saya ada 0.2 mole of NaOH. Therefore, right now, in this reaction, I am having only 0.2 mole of water. And guys, this is what we want. Alright, this is what we want. Setuju kan? Setuju? Ada soalan setakat ni? Tak ada. Okay. Kalau tak ada, saya nak padamkan sebab tak ada tempat. So kita dah dapat number of mole of water kat sini. Kita dah dapat number of mole of water. We can move on. We can move on to the calorimeter concept. So the heat release right now by the neutralization. Everybody knows that neutralization will release heat. So okay, heat release by neutralization. Siapa akan absorb untuk neutralization? Soalan cerita tak apa-apa pasal calorimeter? Tak ada. Alright, tapi apa yang kita ada dalam ni? Solution. Haba siapa? Haba akan diambil oleh apa? Bila base masuk, bila acid masuk, kita dapat satu benda panggil solution. Siapa yang akan jadi panas? Solution tersebut jadi panas. So the heat released by the neutralization will be absorbed 100% by the, bukan calorimeter, by the solution. Calorimeter soalan tak bagi dan soalan tak tanya. Bila soalan tak bagi dan soalan tak tanya, kita assume calorimeter kita tak menyerap haba. Oh my God, Mr. Lim. You're totally like chip small today. Your internet is horrible. What's wrong with everybody internet? Oh my God, in, out, in, out, in, out, in, out. Oh dear. Oh my God. Saya sedih tau, saya sedih sebab I don't think you'll get anything when you're in and out like that. Tu, bilik Anis okay, bilik Lau okay, Nabila okay, Hani okay, pergi lepak bilik dia. Oh tapi sekarang tak boleh lepak bilik kawan. Oops, tarik balik lah, tak jadi. Okay, so the formula that we will use is MC delta T, your M solution, your C solution, and your delta T. So your mass of solution 500, kita dah kira tadi. C solution soalan bagi 4.2, so kena guna 4.2, tak boleh guna 4.18. Delta T is the one that we have given in the question 5.4. So over here you will get your Q release. Your Q release make sure is in joule first. Alright, semua orang patut ada dalam joule terlebih dahulu. And the Q release that I have over here, correct me if I'm wrong, 11340. Yes? Nangguk, okay. And macam saya cakap selalu sangat, nombor ni biasa nombor besar, tukar kepada kilojoule. Bahagi 1000, 11.340. Sentiasa buat yang ni. Sentiasa buat yang ni sebab it makes your life easier. Alright, because the value is going to be big. And this heat release is when you have 0.2 mole of water only. Bila 0.2 mole of air dihasilkan, kamu akan bebaskan negatif 11.340 kilojoule. Question asking for enthalpy of neutralization, where we are looking for 1 mole of water. 1 mole of water release how many kilojoule? Okay. So the enthalpy of neutralization over here equals to your line is quite bad, so I don't want to waste my time asking question also. Ada yang saya nampak mengangguk tu, okay lah. Alright, kalau saya tanya kamu just mengangguk lah sebab you're just in and out, in and out. Saya pun tak tahu. Tu baru saya tak habis cakap in and out tu Alif dah keluar. Okay, if you look at my answer over here, kalau saya letak ke atas, saya tulis kilojoule. Perasan tak? Kalau saya tulis kat bawah, saya letak kilojoule per mole. Nampak beza? If you decided to leave your answer over here, your answer should come only with the negative, of course the negative, but only in kilojoule. Why only in kilojoule? Because the 1 mole is already here. Okay, the 1 mole is already there. So tak payah letak per mole dah sebab kita dah memang compare dengan 1 mole. Tapi kalau kamu tulis balik jawapan kamu tulis balik delta H neutralization equals to negative berapa? Kilojoule per mole. because that is for the enthalpies of neutralization. Makes sense? All right. Thank you. Alif, you okay, Alif? Ifan Kilo, oh my God, your line is so bad. So bad. All right, question so far? No. Setakat ni, are we still together? Okay. Saya nak bagi jawapan akhir je untuk kamu cuba. Kalau kamu kira 2000 kali pun tak dapat jawapan saya, dan kamu tanyalah jawapan saya salah lah kot. Okay, just ask me if my answer is wrong. For this question 8, I think the delta H neutralization that I calculate is 56.25 kilojoule per mole. Kita baca sikit soalan ni. Quantity mixed with in a constant calorimeter have a heat capacity. So yang ni adalah C besar calorimeter. Initial temperature of HCl. Initial is the same. Final temperature mix. Calculate the heat change. Okay. Just a quick one for you. The heat release by the reaction will be the heat absorbed by the calorimeter. Sebab soalan mention pasal calorimeter. And also absorbed by solution. Dua-dua. Okay, check yang ni Check yang ni. Saya bagi tips yang ni je. Okay, yang lain boleh buat sendiri. Soalan bawah. The enthalpy of neutralization. Kira kat sini delta N neutralization of my question over here. Negative 57.12 kilojoule per mole. Heat capacity of solution, tak ada calorimeter. So the heat release by the reaction is only absorbed by the solution. Okay? Can I touch this question a bit? Just very little before we move on. Do you realize you have two initial temperature? So how can I find the delta T? You need to take average. You need to take the average of the initial, which means 21.2 plus 21.6 over 2. That is your average T initial. Baru tolak dengan 35 degrees Celsius. So over here, kalau tak silap saya, you will get 21.4 degrees Celsius. Okay? So delta T kamu akan jadi 35 minus 21.4. Make sense? Yang ni je beza dia saya rasa. Alright, when you have two different initial, you need to take the average. Lim, maybe you want to off your webcam. Because it's terrible. You've been in and out all the while. Yeah. I hope it's better for you. Okay, yang lain okay je kan? Alright, boleh? Okay, and sama juga saya rasa saya ada soalan yang kita tak bincang ke atas. Let me just give you the tips for it. Heat release. Okay, yang ni adalah water and calorimeter sebab ada dua-dua. Alright, your question 5 is your water and your calorimeter because you have both. And the delta H combustion, standard combustion is negative 524.92 kilojoule per mole. Okay, standard, so kena ada not. Okay, 6. Heat release. Ada water juga, absorb by the calorimeter and absorbed by the water. H2O, yes. Okay. All right. And the question over here. Calculate the amount heat release saja. Dia tak cakap enthalpy apa. So the Q that you calculate, the heat release that you calculate, soalan ni senang je ni. 24.68 kilojoule. Tak ada per mole sebab kita tak tahu siapa punya. Okay. Alright. So far so good. Senang calorimeter? Calorimeter senang. Mau konsep tak senang, Miss Law? Calorimeter senang. Inilah calorimeter. Alright. Calorimeter tak ada masalah. Calorimeter senang. This is the calorimeter. This is calorimeter. And this and the formula. Inilah calorimeter. Calorimeter senang je. Tapi ni susah. Welcome back to second semester. Alright. Yang kamu tak pernah nak ambil K1, tengok balik your topic 1 last semester. Okay, semua ni adalah limiting reactant. Semua ni adalah mole ratio. Okay, I want to go into a bit of your Hess's law today. Just very simple. Aku sedih bila aku tengok line hampa tak elok macam ni. Duk keluar masuk, keluar masuk, keluar masuk. Aku stress betul lah weh. Hey, Saya tahu kamu pun stress. Saya tahu kamu pun stress. It's okay. We'll get it through together. Okay. If I say calorimeter is simple. If I say the calorimeter concept, if I say calorimeter concept is simple, Hess's law is even easier. Concept senang. What Hess's law is talking about, remember the vector we learned on Monday? Remember the vector we learned? That is Hess's law. And Hess's law in your daily life adalah, kalau saya ada kat KMPP, saya nak balik ke Johor Bahru. Ada banyak cara. Cara pertama, saya naik flight. Mahal gila. Tambah-tambah sekarang naik flight lagi mahal. Naik flight tapi laju sampai. Cara kedua, saya tak nak naik flight. Saya naik bus, saya pergi kat KL. Sampai kat KL, saya naik ETS. Saya sampai kat Melaka. Alright. Sampai kat Melaka, saya naik bus pula pergi kat JB. Alright. Soalan pertama saya, destination kita tak berubah. Betul? I am still departing from KMPP. I am also still reaching JB. Unless maybe you want to off your webcam so that your line can be a bit better, I hope. Okay? But what makes it different adalah alright. But what makes it different adalah the time and the money. Kalau yang saya ambil bus, saya ambil ETS, saya ambil bus, dia murah. Dia murah. Mungkin sangat murah. Tapi dia ambil masa. But at the end of the day, what are we talking about is I want to reach the same destination from the same place. So that is what Hess's law is trying to tell you. No matter what road you are taking, no matter what is the steps that you are taking, all right, one step or a series of steps, the enthalpy will be the same. The enthalpies that you are calculating will be the same with one condition. The initial and final are the same. Kamu bertolak dari mana dengan destinasi kamu kena sama. Contoh yang ni. Okay, contoh Kalau teacher nak tukar daripada A kepada C. Yang saya nak tahu adalah delta H1. Remember the vector the other day? Alright. Delta H1 yang kita nak cari. So saya ada dua cara tau nak dapat A kepada C. Satu, saya tukar A terus kepada C. Satu lagi, saya tukar A kepada B, saya tukar B kepada C. Pun dapat juga benda yang sama. So jumlah delta H1, your delta H1, the vector that we learn, will then equals to the delta H2 plus your delta H3. This thing. That is what Hess's law said. Okay? Itu sahaja. Dan your Hess's law ada 3 cara nak kira. Okay? Hess's law ada 3 cara nak kira. Jangan risau, we only have 10 minutes left. Saya takkan dan ajar 3 cara. We will go for the easiest one. The easiest sebab dia paling pendek. Tapi disebabkan dia paling pendek dan so-called easiest, budak akan buat salah. 90% budak buat cara ni, 99% budak buat salah. Saya akan ajar yang paling senang dulu. Algebraic method kita akan tengok esok malam. Energy cycle kita akan tengok esok malam. Jangan risau. Okay. Saya nak pergi kepada formula method. The formula method the formula method means dia kena ada formula lah. So the formula over here is the delta H reaction will be equals to the total H formation of the product minus the total H formation of the reactant. Okay, ingat formula ni sikit. Total total H. Buruknya total aku. Total, sum. Okay, ingat yang ni. So, formula soalan yang kita boleh guna formula soalan 5. Take a quick look. Okay. Kenapa saya kata soalan 5 boleh? Perasan tak dia bagi formation? Remember I say in the formula just now? Alright, kita hanya boleh guna kalau yang diberi adalah formation. Okay, kita tengok yang lain. Formation, combustion. Boleh guna cara formula? Tak boleh. Right? Tak boleh. Yang ni. Dia bagi combustion, dia bagi vaporization. Tak boleh. So tak boleh guna formula ni. Nampak tak yang ni? Yang ni semua adalah combustion. Saya tak tahu kamu perasan ke tak, tapi semua adalah combustion. One more. Semua ni sebenarnya delta H combustion. Tak boleh guna formula. Nampak? Nampak dah bila masa boleh guna formula? Sebab bila saya ajar formula, formula adalah benda yang saya tak suka ajar sebenarnya. Tapi ada soalan yang memang senang guna dia. So saya kena ajar juga. Tapi bila saya ajar formula, hang start mengapa dah. Hang bila dah ada cara senang kan, hang tak nak guna cara susah dah. Alright, dia start lah semua benda hang nak jawab guna formula. Yang tu saya tak suka. So make sure kalau nak guna formula, yang kamu ada dalam tangan adalah formation. Itu syarat pertama. Okay. Yang kedua, kita tengok equation. Bila kamu ada soalan formation, soalan nak guna formula, kamu mesti kena ada balance equation yang kamu nak cari. So, this is the delta H reaction that I'm looking for. Saya guna reaction tau. Dia tak kisah apa dah. Alright, dia tak kisah apa kat sini. So, kind reminder over here, I hope you know they are reactant. I hope you know they are product. Agree? Okay. So going to your formula, your delta H reaction will equals to the sum of the formation of your product minus the sum of your formation of your reactant. Okay. Now, I just want to look at one simple product. Kita tengok dulu CO2. Kita tengok CO2. The one that given over here is delta H formation of CO2. Negative 394 kilojoule per mole. Okay. Kalau saya tulis equation ni, am I right if I write it this way? Oops. Am I right if I write it this way? Alright? Betul? Soalan saya. Enthalpy of formation, ladies and gentlemen, 1 mole. Siapa pegang? Product or reactant?
Compound. Product.
Product. Compound that being formed. Betul? So, betul tak Miss Wong cakap 1 mole CO2 akan hasilkan negative 394 kilojoule. Setuju? Okay, we are moving on . So everybody agree. Okay, saya nampak Lau je mengangguk, lepas tu Anis duduk mengangguk sikit-sikit, Hani duduk mengangguk sikit-sikit, so saya assume yang lain pun agree lah. Yang ni je yang saya nampak, yang lain tu duduk keras macam tu je muka dia. So, bukan tak nampak yang lain dia line slow eh. Okay, 1 mole akan bebaskan tenaga banyak ni. Cuba tengok soalan kamu, berapa mole CO2? So, do you agree if I say my product adalah 2 kali negatif 394.0? Nampak ke kenapa darab 2? Okay. So, if you understand this, it shouldn't be a problem for you to understand the next one. This one. Ethanol formation of ethanol. Formation of ethanol is negative 277.8. But do you agree that the negative 277.8 hanya adalah untuk 1 mole of ethanol? Right? But right now, I have 2 moles, ladies and gentlemen. I have 2 moles. So, kita akan tambah 2 kali negative 2778. So far, so good. Ada soalan ke sayang? Ada soalan ke? Okay, benda baru. Yes, benda baru sebab kita tak bermain dengan 1 mole. Kita bermain dengan 2 mole sekarang. So, kamu kena nampak bila masa nak darab 2. And reactant senanglah, kita bagi bernafas sikit. Reactant senang. Reactant, kita hanya ambil terus negatif 1260. Before you move on to your calculation, just a quick check. I hope you realize we are taking in all the sign that you have in the delta as always. Kita tak ambil value ya, kita ambil semua benda termasuk the magnitude, termasuk simbol positif negatif. And to make your mathematics easier, untuk kamu nampak the positive negative, this one will be negative 788 plus negative 555.6. Negative, positive 1260. Betul? So matematik akan jadi negative 1343.6 plus 1260. Kenapa saya insist benda ni? Sebab nanti jawapan akhir, guys, jawapan akhir kamu, positif or negatif? Negatif. Thank you. Negatif. Alright. Negatif, tolaklah sayang. Kilojoule. Kilojoule sahaja sebab delta H reaction yang kita kira, kita tak tahu dia reaction apa benda. Betul? Dia bukan enthalpy yang kita belajar. Dia bukan apa-apa enthalpy yang kita belajar. So kita tak tahu 1 mole jatuh kat siapa. So, kilojoule sahaja. Happy or not happy? Saya kata senang, tapi kenapa saya kata selalu budak buat salah? Sebab kamu tak tengok stoichiometry. Kamu bila tengok formation, kamu pun ambil lah formation product, tolak dengan formation reactant. Hang tak tengok dah 1 mole ke 2 mole ke, hang tak ingat dunia dah. Hang buat je. Kena check stoichiometry. Tolong check stoichiometry. This is the thing that you need to check because when it's formation, everything is only given in 1 mole. So whenever you need 2 mole, you need to times 2. Whenever you need 3 moles, you need to times 3. Make sense? Boleh? Okay. Senang. Sangat senang. Jangan buat careless. Jangan excited. Okay, jangan excited. And we have a few more question, tak banyak. Ada 3, 4 soalan lagi kalau tak silap saya. If you would, alright, if you could, try to look at the notes. Sebab nota saya ada bagi contoh yang sangat detail. Saya tunjuk step by step. Okay, saya bagi tips lah. Okay, saya bagi tips soalan 1 ni. Saya bagi tips untuk soalan 1 dan 2. Supaya kamu cuba at least. Soalan 1, if I'm looking at it, I think both can be done. Let me check. Yes. Yang ni kalau nak yang ni cuba algebraic method. Alright, yang ni cuba algebraic method. Dia boleh dua-dua sebenarnya, dia boleh dua-dua. Kalau kamu nak try pun boleh, dia boleh energy cycle juga. Alright. Soalan 2 pula, saya nak bagi yang senang je. Soalan 2 saya rasa algebraic senang. Sebab dia melibatkan banyak. So macam ni lah. Soalan 1 tadi, cuba energy cycle. Soalan 1 kita cuba energy cycle. Soalan 2 cuba algebraic method. Cuba buat. Cuba buat sebelum kelas kita esok malam. Dan tengok cara yang kamu buat sama tak dengan apa yang saya akan tunjuk nanti. Then you will be good. Of course, if you have tried your question 1 and 2 and if you think you're okay, you can move on. Soalan 3 you can move on, soalan 4 you can move on. Tak banyak, tu je soalan yang saya bagi. Alright? And personally, I prefer if you are not requested for energy cycle method, Hess's law saya rasa senang lagi algebraic method. Okay? Bukan semua soalan boleh jawab guna algebraic method, tapi most of the soalan yang keluar boleh jawab guna algebraic method. So take a quick look, pay a bit of attention on your algebraic method. Okay? Boleh. So I will see you tomorrow night for this Hess's law. Kita akan sambung Hess's law dalam 1 jam. And then another 1 hour kita akan masuk Born-Haber cycle. Depends on your performance. Kalau saya puas hati malam esok, dan itu sahajalah extra class kita minggu ni. Kalau saya tak puas hati malam esok, dan kita akan jumpa lagi hari Sabtu malam. Prepare. If you prepare, I know whether you prepare or not. So prepare. Okay? And you'll be good. Alright, ada soalan setakat ni? Nope. I am so sorry that your line is terrible for some of you. I will upload the recording as soon as I can. Kalau malam ni saya tak upload, remind me. Saya lupa kadang-kadang. Saya balik kalau saya buat kerja, saya tanda lab report. Lately saya duk tanda lab report, saya tanda guna iPad je. Saya tak buka laptop. So saya tak upload video. So if I forgot tonight, then you text me. Okay? Alright, I'll try to upload it by today so that you can watch it by tonight. And if any question, ask in the WhatsApp. Kalau terlepas banyak sangat. Your class is horrible. Kelas saya tadi yang lain okey je. Kelas kamu macam cheap semua betul.